Great, thank you very much, Andrew. Is that all okay? It seems right. Great. So I've got a little bit more of a talk about the work that I do at the Met Office, but I will talk a little bit about me first. Lots of things actually in Avery's presentation actually really resonated with me around not having a community of sort of like-minded people at school. So I'm a little bit older than Avery. I'm sure you can't tell at all, but there were very few LGBT people at school. Just wasn't really a sort of thing. So I was very sciencey and very academic. So that kind of made me an outsider in other ways. I ended up originally going to university to do maths at Cambridge, and I really did not get on with it. I felt very out of place. I came from a working class background, and so I left there with quite severe depression. And I've suffered with depression all my life, which people are very surprised to learn about me because I'm also an expert masker. Debatably may have, some elements of ADHD or autism, but haven't been diagnosed. I mean, one of my partners has said to me, I thought, because I said, on seeing lots on Facebook about, women with ADHD and being like, oh, this really resonates with me. And he's like, oh, I thought you knew you had ADHD. Oh, sorry. Anyway, so we're living in a brand new world where we're learning more about, so I think I was maybe the MSN Messenger generation when I was at school. So there wasn't a whole lot of content then. When we're learning more and more about ourselves as, So I eventually ended up studying oceanography and getting into climate science that way. But along the way, I've always done quite a lot of communication around science and also diversity work. So I'll talk about that as we go through as well. So, and I work at the Met Office, hence the front slide. So, because we had got this award for being a great place to work for women at the Met Office last week, and I was made to take some new headshots. So I now have a nice headshot of me looking a bit more authoritative because I had these lovely smiling headshots, but then unfortunately I do a lot of media work telling people how many more extreme hot days we're going to see in future, and the smiling headshots just seem a little bit not quite right. So this is my new headshot. And I identify with the B and LGBT. So I've added that little flag there. So thinking a little bit more about my work, the specifics of that. Starting at the bottom, really, came very much physical science, looking at temperature trends in the ocean through my PhD in the deep ocean, in fact, so below 2,000 meters. So quite niche there. And then when I came to the Met Office, well, I did a postdoc at the University of Exeter first on the changing Atlantic Ocean, but over quite long timescales of hundreds of years. And then I came to the Met Office and have been working on compound or multiple hazards. And that's when you've got two or more things happening at the same time or close together. So that's a kind of emerging area of thinking about how climate is going to affect us. So I'll talk a little bit more about that later. And then I really focused on the UK and Europe, climate change, building more climate resilience and adaptation. So it's a lot more in the applied science area. It uses a lot of communication in itself, working more with users to try and make climate information useful for them so that they can make better decisions around climate change and both mitigating, which is like lowering the emissions that we're making to sort of result in climate change, but also adapting, because we are already seeing impacts from climate change, which I'll talk about as well. So that means that I'm a bit more of a climate change generalist now, I feel. So it's 14 years studying and working on climate science across different institutions. And throughout that time, I'm talking a lot about climate change, ending up climate communication, trying to inspire women and anybody else who's underrepresented in science communication, which is pretty much anyone who's not a 50-year-old white man. So unfortunately, that's meant that I've had to do some of it myself, which it's not, you know, I don't mind, but I'm also like, you know, I'd like to be coding and doing technical stuff and not just like talking to the media, but you know, I'm doing a bit and some diversity in science work. So I'm actually wearing one of the yellow shirts, which means that I'm a coordinator of the PRISM network. So for the last 4.5 years or so, I think I've been helping Claire in a very minor way, mostly because I also run another network called Women in Climate. So I unfortunately would, you know, love to be paid to do this all the time, but I'm actually paid to do science. I have to do some science as well, and then I get to do this as well. But I mostly work with very big model data, so that's a lot of coding as well. So for Adventures New, I'm currently a data science apprentice at the University of Exeter as well. I feel quite strange attaching the name apprentice to me, but you know, I'm just learning all about machine learning and how we can, well, and then thinking, you know, I will take that back and think about how we can better utilize machine learning in the applied science problems that I'm trying to do, because it's not, although there is a lot of machine learning potential applications in weather and climate science, it's not really an area where we use it a lot at the moment. So I'm just going to start talking about weather and climate, and this is going to kind of roll back round to the end, because hopefully you're a bit familiar with the concept of weather living in Britain. Every day is a bit different, so sometimes it's very hot and sometimes it's very cold. I think you're all like more sciencey minded people, so you're probably already aware that the weather doesn't actually tell you much about what's happening over a longer time scale. So hence we have this concept of climate, which we tend to think about as the average weather over a long time period. So that might be 20 or 30 years. However, we are moving to a new seamless world where we're thinking about the changes that we want to make tomorrow. So do I want to take a coat to work tomorrow? Do I want to prepare for a, you know, 1.3 degree warmer world that we might see quite shortly? Do I want to prepare for a 2 degree warmer world, which we also might see slightly less shortly, but it could not be that far off. So we're thinking on all these different timescales, right? So we've got this idea now of this sort of seamless weather and climate problems. So we're thinking very much about extreme weather events, but also how much more frequent are these extreme weather events going to be in future. So it's not really possible to completely detach weather and climate anymore. We're actually working together, and the more time now I spend as an applied climate scientist, the more I start thinking about meteorology, which is actually something I didn't really study, because I find, you know, with having to understand extreme weather events, then you actually, you know, need to learn about the convection of a thunderstorm or things to be able to talk about how this is likely to change under climate change. So I'm always learning. Of course, the really crucial driving force behind the work that I've been doing since I started oceanography, really, because the oceans are a very important part of the world climate system, is driven by this graph. So you know, you can look back a long time to see that as humans have evolved, we've had a very nice but climate, which has allowed us to, you know, dominate the world and these sorts of things. So however you might feel about that. But unfortunately now, as we're going, we've been doing a bit of an experiment with fossil fuels, and the temperature is going up quite a lot. So this is one of the more recent reiterations of this graph. So whatever, you know, there's a lot of people spreading misinformation on the internet, but you can see that whatever kind of reconstruction of temperatures over the past 170 years, there's a very clear pattern. And that's not just true over the globe, it's also true in the UK. We've had some very warm years recently, 2020, 2022, both very warm. And so we've got this Ed Hawkins designed these climate stripes idea, which has actually become one of the most symbolic climate communication ideas that we have out there at the moment. So you see it now everywhere. You see it on Reading Football Club strip. So that's quite interesting, that this, you know, simple reds and blues to communicate the warming has appealed to the population, which is really nice to see. So I don't make this graphics. We have very clever people in the design studio who make things look prettier. So you know, I don't make anything like this. I tend to steal it from my colleagues and then talk to other people about it. It's very much a kind of group effort at the Met Office, which is something I really like, versus academia, where I had to kind of do everything myself, unless you're you know, you've got a kind of budget to get the professionals to help. So obviously we're quite lucky in the resources that we have, and the press office to help us with media opportunities and things like that. So these next graphics are some graphics talking now about what's going to happen in the future. So you know, we've got to this situation now where, as you'll have seen in the news, things are getting rather hot in lots of different places. We're very likely to have warm years in the next few years, likely to start hitting this sort of 1.5 idea quite at least temporarily quite soon. I mean, you know, it's an open debate when you say, well, if we've hit 1.5, are you going to say, is that over an average of time? So, you know, we know that we are getting these sort of record-breaking events. And of course, these are having lots of different impacts. So we've got lots of what we call our hazards, which is like the temperature changes that we're seeing, the rainfall changes that we're seeing. And then these are causing the things that happen to our local world as humans. So food insecurity, damage to housing, heat stress, and these things. So, and this is really key to what I do now, is actually trying to go from understanding just about the temperature change or the precipitation change to the things on the outside of the diagram. What does this mean for people, and how can we help people make decisions to stay safe and thrive, which is our Met Office purpose. So a few more things here about these extreme weather events that we're seeing as well. So these are just some examples from some slides from last year, because unfortunately these events are getting very common. So it's a very interesting time from a scientific perspective. But we also have what we call event attribution scientists at the Met Office. So they basically run a model with the oil, the emissions from burning coal and gas, so what we expect to have seen, and then one without. So they run this model with both these different situations, and they say, well, how much likely is it to have been if we didn't have this human influence? So you can say, well, it was 10 times like it was, you know, going to happen 10 times in 1,000 years or something with no human influence. But then when you add the human influence, we see that it's now happening 200 times, for example. So then you can get this estimate of how much more likely it was likely to happen. So this is something that is quite a good communication tool for scientists. It's getting in the media. And so you have these headlines now saying that we know this event was due to climate change. It was 100 times more likely. So in the case of the India and Pakistan heat waves, that was thought to be over 100 times more likely because of climate change. Flooding is it's harder to kind of detect these changes in rainfall as it is temperature, which is very clear, but it's still thought to be you know, maybe up to 10 times, up to 9 times more likely there, but also the rainfall would be more intense due to climate change. So there's this changes to how we're seeing, say, more, which is why we get more drought conditions, but also very heavy rainfall. So these things can be quite confusing to communicate, because you're in one way saying to people it's going to be less wet because you're going to see drought, but then sometimes it's more wet and we get very heavy rainfall. So both these things are true, and we're talking about quite a complex climate system that we're trying to communicate. And then the Siberian heat wave there was shown to be 600 times more likely due to climate change. So this is very, very strong evidence for people that climate change is impacting us. And also in the UK here, so last year we saw 40 degrees, which was, you know, quite a record-breaking situation in one station, but we also saw it across many different places, getting very close to this or breaking the previous record. So we had a red weather warning for heat, exceptional spread across the UK with Wales and Scotland records falling. You know, we've had very heavy rainfall, and flooding is kind of becoming increasingly common. The example here is from 2020, but very new research released this year shows that by 2080, this extreme rainfall could be 4 times as frequent than it was 100 years ago. So, you know, that's that intensities here. And wildfires, of course, as well, dry, hot weather could be more than 5 times more likely in the UK. So although we do have the capacity to make changes in the UK, you know, we're in that situation that we can invest in these things, but we are going to still see these impacts, and it's not just something that's affected other parts of the world, it's affecting us here as well. But obviously across the world in devastating ways, where people are losing their homes and having to migrate as well. So so that's very much that hazard idea still, but we're literally trying to go to the local level in the work in the teams that I'm working in the Met Office in applied science. So health, for example, you know, how hot and humid are we going to see more people in hospitals, you know, especially when they are already stretched at capacity? What additional challenges is climate change going to bring? Emergency planning. Really important when you've got lots of extreme weather events and maybe they're happening at the same time or close together. Emergency responders need to be able to help people. You know, our natural environment, whether it's like cultural, tourism, very important in this part of the UK, for example, is also something to consider. And transport is obviously affects us all. Railway lines down to Dawlish were of course swept away by storm surges as we see more sea level rise, more extreme high level waters will come because you've got an additional raise in the sea levels, and then, you know, you might have so you will get more storm surges coming. So lots of infrastructure's quite vulnerable to that. So I've been at just last week was a workshop in Birmingham where we were discussing hazards to the rail sector and to the energy sector. So, you know, transport is a really important one. And actually the Met Office does do quite a lot of work with rail, marine and aviation as well. So even though obviously aviation is contributing quite a lot of carbon emissions, but you can do things like understand how weather is going to help or hinder a plane journey so that you can optimize its route to take advantage of the weather and therefore use less fuel. So there's things that you can do there to kind of make improvements. Buildings, overheating. Colleague in my team is working on overheating in schools and the risk to that in the future. So, you know, it can be hard enough to teach kids just before the summer holidays without them like overheating in a heat wave as well. And then, of course, our utilities, energy, water, all things that we really rely on to fund all our other sort of local services as well. So that's a really important part of our work at the Met Office, is to work with these different people or sectors, as I might say. So we understand this idea of hazard, the temperature, precipitation, and then, you know, we want to understand, are you going to be affected by this? Are you going to be exposed to that risk? So that's the idea of exposure. And vulnerability is, well, when is this going to be a problem for you? Is heat going to affect you at 20 degrees, 30 degrees? Like what is your vulnerability? Have you got old people in your care home that are going to be more vulnerable to hot weather, for example? So there's a lot of social science coming into this idea of combining this temperature information with other information about society to kind of move to this idea of what is actually risk. How is it actually going to affect us at the local level? And so climate adaptation, I've probably mentioned the word quite a few times, this idea of some changes, and it is now essential. We are already locked into some impacts of climate change. You know, we can't avoid some impacts now. So we're already experiencing some impacts that I've talked about. But even if we were magically able to stop emissions tomorrow, we would still be committed to further impacts, because we have this big complex system where there's lots of heat moving around the atmosphere and into the oceans and changing the dynamics of how that system operates. And so the changes as that system responds to the changes that we've already made will cause different impacts going forward. So we're committed to impacts, but we also know that we are likely to continue to emit some amount of oil and gas for some time, emissions from oil and gas for some time. So we need to plan for what we are likely to do, and also think about what may happen, but also worst case scenarios, so that we can be prepared depending on, the sector that you're in. For example, nuclear energy sector needs to be, very prepared for extreme weather, because it is a big risk to life if you have a problem with something like that. And also transport, we would like to be very resilient to extreme weather. Whether it is or not may be debatable. But, it depends on the decisions that a particular sector wants to make as to whether what level of climate change they prepare for. But the Committee for Climate Change, which is the government's sort of appointed body in the UK for advising government about climate change, says we need to prepare for a 2-degree, but we should also be considering preparing for a 4-degree world, because that is still a very plausible outcome. But the quicker we do it, the less likely that limits to adaptation are reached. And there's this really critical time element there. So we do different things, like we have our weather warnings at the Met Office. We have this middle diagram's meant to talk about like model projections of the future. And then also kind of new portal-based technology, so people can go in and see how things are likely to change near them in a more interactive way. And so this is a very, very basic sort of model idea of what models are. You've got people in the audience who can tell you a lot more if you want to know. Essentially, I talk about models as being a way to represent something approximating our best understanding of the physics of weather and climate, or the best that we can do when we're using little grid boxes to cut up the earth into little chunks. What is important here is this different ideas of weather and climate, because when we're talking about weather or seasonal predictions over the next months and weeks, this very short-term chaotic behavior is very important. But over decades, we have uncertainty, because we know there are things in the model we don't capture well, and also we don't know what humans are going to do. So we have all these different sources of things that we need to understand quite well, where they're bringing in error into the models. So that requires a lot of expertise. But on the whole, models do a really good job of capturing the long-term climate change. So models run in 2004, which projected the future for 20 years, captured this 20-year climate change really well. So we're continually improving models, adding new processes, increasing complexity, which requires a lot of computing power. So you might know the Met Office has supercomputers, is getting ever more powerful supercomputers. And it's true of our weather forecasts as well, actually. So our 4-day forecast is as accurate today as our 1-day forecast was in 1980. So predicting the weather in Britain, very changeable, very difficult, but it is getting better. We're getting new forecasts very regularly, that will go to customers in various sectors. So people do get up-to-date forecast information. And really one of the big concepts that is this kind of push and pull between what society kind of wants from a climate modeler and what we can give them. Is this something I've tried to encapsulate with this idea of a dartboard? Because you really want to know exactly what's going to happen very accurately, and that would be brilliant. And then we can say, oh, right, you need a wall exactly this tall, and you don't need to spend any extra money, and it's all going to be fine. But unfortunately, we don't know exactly what humans are going to do in the future. We could give a very precise estimate, and would probably be wrong. So we often supply this range of different ideas. So when you look at future projections of climate graph, it looks a bit more like a plume, because it could be this or it could be this, which is going to give you an accurate answer of what's going to happen in the future. But unfortunately, kids are with people feeling a bit frustrated by climate scientists, but unfortunately, we don't have a crystal ball. So just before I finish off, talking about a couple of projects that I've been involved with over the last few years. The UK Climate Resilience Programme was a big programme across lots of different universities in the Met Office, running between 2019 and 2022. And so really this idea of looking at climate risks and useful information for climate adaptation and services was really important. So it's very a broad project, and a lot of the research that done on climate resilience over the past few years was funded by that programme in the UK. Specifically, what I was doing, well, the first thing I did really was looking at compound events impacting UK agriculture. So high temperatures and high humidity could lead to different hazards, like the cows getting stressed with getting hot, but also potato blight, which is a bug or a fungus, sorry, that grows on potatoes when they get hot and humid, either in storage or in the ground. And either way, it's bad news for agriculture. And although I did the typical thing of publishing this paper, you know, it also really picked up, partly due to the great work the press office did in liaising with farming media, and got my name on like page 3 of the Telegraph, which I didn't ever expect to happen in my career as a climate scientist, but there we are. Did interviews on BBC4, Farming Today, things like this, lots of social media, as well as the typical academic conferences and stuff like that. So that was really turned into quite a climate science and climate communication adventure in itself. Unfortunately, the next thing I did was quite a lot less interesting to the media, because I was literally just looking at relationships between temperature and precipitation and how well that was captured in models. So it sounds a lot more technical and not very interesting, but unfortunately understanding how well the models are doing is also quite important. So, and I do quite enjoy the coding and things that go into this more technical work as well. So you don't need to worry about the specifics of this, but if you are really interested in the niche work I've done and want to read the papers I've written, you know, feel free. And I'm going very much the other way at the moment in a project that I'm working on. It's called Aspect, and the Aspect is about it's seasonal predictions of European climate, but so the A is actually adaptation orientated seasonal predictions of European climates, because we like acronyms, and eventually if you twist it enough you can make Aspect out of that. And so actually what I've become now, I'm advertising for different organizations to work with us to help them make better decisions. So I'm feeling like I'm, you know, messaging newsletters and things to kind of reach out of the bubble of people who we typically work with, which is quite nice that we're funded to do this, because of course you have sectors that can come and pay money to get information, but there's also sectors that don't necessarily have that time and capacity. And so that's why I did some work with agriculture a few years ago, because it is something that was falling behind in its understanding of how climate change is going to affect it. So hopefully, you know, we can work more with sectors like transport and health, which are really societally important sectors that are maybe not well prepared, through projects like this. So in a few months, hopefully I'll get back to doing something technical, but I'm you know, advertising at the moment. And then just to finish off, a couple of other things. I've done various different outreach things over the years, but something I'm particularly proud of was my involvement in kind of representing the Met Office to make this project happen. So this project was run by the two people on the top left, hot poets, and they got 12 poets to work with 12 different organizations. And so we worked with Elvis McGonigal, who's just to the top right there, and he wrote a poem about the Met Office, which you can watch on YouTube, called Extreme Weather Report. And these poems like went to COP, and they've all been filmed on YouTube as like little videos. And it's a really nice way of, I mean, you know, I could do something and write a poem about climate change, but it wouldn't be very good because I'm not a poet. So this way I could witter at a poet and get all my friends at the Met Office to witter at the poet for a day to fill his mind with all these ideas, and then he went off and wrote a poem about it, and it was all filmed, and then, you know, we can use it on social media, and as I say, I had them at COP26. So I was actually involved in the Met Office Science Pavilion at COP26 in Glasgow, which is the big conference where governments talk about commitments to climate change. And so I also showed that, so I did a Poetry Power event that project was part of, as well as another project from the University of Exeter. But I also did an event about what women bring to climate science. And so, as I said, I lead the Women in Climate Network, was asked to do this because of my experience hosting events for the Women in Climate Network. And this had some very, very senior women from organisations like the World Meteorological Association, as well as our chief exec at the Met Office. So a really interesting discussion there, which again was all filmed and streamed live to people on YouTube. So I'll just finish locally by saying a little bit more about Women in Climate and the work at the Met Office that we do in diversity and inclusion. So you can find out more about Women in Climate on our website using that QR code. And we've done over 75 different events now over 5 years. So that's a lot of events when you do them monthly. And we've had really big ones like Kate Marvel, who's a climate communicator from America, talking to us, and did an In Conversation event with her, which was great. Occasionally I try and do something new, like work with the people who do TikTok at the Met Office to do a TikTok for women, International Women's Day. And it's really important to me, obviously, as you know, somebody who is queer, and also, you know, probably has some sorts of disabilities, not in a sort of diagnosed way, but although I do still suffer from depression as well, that we work in a really intersectional way. So it's not just a sort of feminism network, it's a very intersectional network. And, you know, I'm involved in quite a lot of the other networks at the Met Office as well. So we have an LGBT network here, and the coordinators of that network are also in the room today. So you can find out more from them as well. So, and we work together to try and have a more of an active attitude towards improving processes at the Met Office, through having all these different networks that sit together on a sort of diversity council. So this is a new strategy that was implemented over the sort of 3 or 4 years ago. And so we're really trying to embed some sort of changes and improvements into what we do at the Met Office. And that's really important, I think. And we work closely with the University of Exeter through Women in Climate, but also through things like PRISM Exeter. So by me being a coordinator of PRISM Exeter here, we've got not just the university academic Met Office, but we're also partnering with different organisations around the Southwest and thinking much more broadly about diversity and inclusion across STEM. So it all kind of links up quite nicely. So I have a very boring slide at the end, which is a lot less colourful. I should do something about that, really. But my email and Twitter handle are there if you want to get in touch with me, or I don't know, LinkedIn maybe is where we're going next. I'm not sure. But, you know, I'll be somewhere on the internet. So thanks very much. I'm going to wrap up there because I've gone quite badly over time. But hopefully you enjoyed that little meander through talking about climate risk and communication.